Could we actually create Spider-Man? Not a costume. I mean wall climbing, super strength, spider sense, webs, the whole thing. Because here's the interesting part. Pieces of this already exist. So let's actually try to build him. And we'll start where Peter did. The spider bite. Could a bite actually change your DNA? Changing genetic instructions inside human cells is real. Gene therapy can deliver new genetic material into cells. One way is with an engineered virus, a viral vector, basically a microscopic delivery vehicle. But Peter doesn't need one little edit. His muscles change, his bones, his nerves, his senses, maybe even brand new organs. One bite would have to rebuild all those systems at once. That's like rewiring, replumbing, and rebuilding a house while someone is still living inside it. Modern gene editing can't do that. And one Spider-Man power needs an even stranger biological redesign, the webs. Spider silk starts with special proteins called spidroins. Think of them as the raw ingredients for silk. The spider stores those proteins as a concentrated liquid. Then that liquid moves through a narrow duct. The chemistry changes, the proteins line up, and solid silk comes out. So if Peter makes webs from his wrists, he needs a system to make the proteins, store them, and spin them. Basically, a silk factory inside his arm. But this is where things get weird. Researchers made a silk-based liquid that leaves a needle and rapidly becomes a sticky fiber. It grabbed a small object and pulled it back. Now this cannot hold a swinging person, not even close. But look at the idea. Liquid comes out, fiber forms, fiber sticks, something gets pulled. That's extremely Spider-Man-shaped science. But a strong web doesn't help much if the person holding it isn't strong enough. The obvious solution is stronger muscles, except muscles are only one part of the machine. Muscles pull on tendons. Tendons transfer that force to bones, and the load passes through your joints. Give Peter super strong muscles but normal human hardware, and his own strength could hurt him. It's like putting a Formula One engine inside a bicycle, or put some of the extra strength outside the body. Exosuits already exist, and they can take real strain off your muscles. In 1 hour-long test, an active back exosuit reduced measured back muscle activity by about 20%. Useful? Yes. Spider-Man strength? Absolutely not. So we can help Peter lift. Now make him stick to a wall. Tiny climbing animals can use microscopic adhesive structures to grip smooth surfaces incredibly well, but there's a scaling problem. Peter is enormous compared with a spider. Scientists compared adhesive pads across 225 climbing species. As animals get bigger, they need proportionally more adhesive area. Scale that relationship up to us, and one estimate suggests close to 40% of the human body would need to act like adhesive pad. That sounds terrible for Spider-Man. Except engineers found a way around part of the problem, and they tested it on a person. Their gecko-inspired devices spread the load across lots of smaller adhesive patches. A 70-kilogram person actually climbed vertical glass using 140 square centimeters of adhesive on each hand. So human-scale wall climbing isn't completely hypothetical anymore. But those aren't bare Spider-Man hands. They're specialized devices on smooth glass. Now Peter can climb. But can he know something's coming before he sees it? Real spiders cannot predict the future, but some have extremely sensitive hairs called trichobothria that detect tiny movements of air. A flying insect disturbs the air, the hair bends, and the spider gets a nerve signal. We can't give Peter precognition, but we can give a suit more information than Peter's own senses, cameras, microphones, motion sensors. A computer could combine all of that and notice something dangerous before Peter consciously does. That's not future vision. But from inside the suit, it might feel a lot like spider sense, which is useful because now we're throwing Peter off a building. Let's say we perfect the web. It's strong. It sticks. Peter fires it at a building and jumps. Congratulations, the web survived. Your shoulder has now discovered physics. At the bottom of the swing, the web has two jobs. It has to hold you up and keep pulling you away from a straight path so you continue moving in a curve. The faster you go, the harder that pull gets. Take one simple example: a 75-kilogram person, a 10-meter web, moving 15 meters per second. At the bottom, the line tension would be roughly 2,400 newtons, about 3.3 times that person's body weight. And Spider-Man often catches that through one arm. So even if the web survives, Peter still has to survive the web. Then there's the other end. If the web is stronger than whatever you attached it to, the building becomes the weak point. A harness could spread the load through more of your body, and a computer could help choose safer anchors. But look at what we now need: a human-safe web, a strong anchor, an automatic reel, a full-body load system, sensors, and a human who can survive doing this again and again. We don't have that system. So can we create Spider-Man? Not yet. But pieces of his powers already exist separately. We can change genetic instructions inside cells. We can reduce muscle effort with exosuits. Humans have climbed vertical glass with engineered adhesives. Researchers have made remotely deployed sticky fibers, and sensors can notice things we miss. The real problem is putting all those pieces together at human scale without destroying the person using them. So the first thing that really looks like Spider-Man probably won't come from one magical bite. It'll start with a normal human, surrounded by some unbelievably advanced technology. If you had the money to build just one Spider-Man power for real, which one would you choose?